Hello, today I'm going to show you how to find the area between x sin x and the x-axis, but when we limit the interval to be from 0 to 2 pi. So if we look at our little diagram I've drawn already, we can see it's basically we need to find this area that's like trapped between the two lines. And one thing we have to remember is when we find the one on the right hand side, the one underneath the axis, that it's going to be a negative value. So when we're trying to find the area between the two, we need to, if it gets a negative answer for that little section, we need to ignore the negative sign basically, and then add the two together. So the first thing we're going to do is we're going to integrate our function, so x sin x. And we'll do that with respect to x. We need to use part by parts with this. So we'll have u as our x, u dash can be 1, v dash can be sine of x, and therefore our v is going to be minus cosine of x. So when we stick everything together, if we label this as I is going to be equal to u times v, which is minus x cosine of x. Take away the integral of u dash times by v. So u dash is 1, v is minus cosine, so the minus will come out the front, and we'll put the cosine x in there. Let's quickly evaluate that. So x cos x comes with us, and cosine integrates to give sine. Beautiful. And we will have a plus c, which will add on. In a second, we're going to evaluate our integral at different, every different region. So we're going to have to, sort of our c will cancel out with each other in a second. We can quickly jot on our values here then. So this is going to be pi in the center, and this is 2 pi. You can confirm this on Desmos and make sure the graph is the same, but it should be that. So we can label our things then. So let's label this one as A, and this one as B. And what we need to find out then is A and B and add them together. So A is going to be equal to our integral, but evaluated from 0 to pi, sorry, not to 2 pi. So when we do this, we stick in our values. We can ignore the c's because they're just going to cancel off straight away. So what we have is minus pi cos of pi plus sine of pi. Take away 0 cos 0 plus sine of 0. Beautiful. So when we stick everything in here, cos of pi is minus 1, sorry. So minus 1 times minus pi gives us pi. And everything else, sine of pi is 0. 0 times cosine of 0 is 0. And sine of 0 is 0. So that's all equal to 0. And if we look at b then, well, the actual area of b, we don't just need to evaluate our integral from pi to 2 pi, but we need to take the modulus of that, so ignoring any negative signs we get. So when we start shoving everything in there, we're going to have minus 2 pi of cos of 2 pi plus sine of 2 pi. Take away minus pi cos pi plus sine of pi. And again, we need to modulus. I know I've not got enough space, but that's the modulus over there. Similar to last time, sine of 2 pi is 0, sine of pi is 0, so we can ignore those. So what we're left with then is minus 2 pi multiplied by cos of 2 pi. Cos of 2 pi is 1. And then negative of negative pi times cos pi. Well, cos of pi is minus 1, so you have 3 negatives, which means 1 negative, so that's a minus pi. So we can ignore inside this it's going to be minus 3 pi. With the modulus, that makes the whole thing 3 pi. So now then, if we think about the total area, is going to be a plus b, which is pi plus 3 pi, which equals to 4 pi. Beautiful.